Question B2. Question B2 is in three parts. The first part, discuss reasons why ventilation is necessary in an occupied building. Second part, describe in detail the two main driving forces governing natural ventilation into and out of a building. And the third part is calculation. A building has a volume of 500 meters cubed, experiences a ventilation rate of 2 air changes per hour. The indoor temperature is 22 degrees centigrade and the outdoor is -3. What's the heat loss due to ventilation? So for part one, why do we need ventilation? Well, primarily we need ventilation to remove body odours and contaminants, pollutants within the atmosphere, and these pollutants can be man-made or they can be natural. Things like radon gas, naturally occurring sort of a problem in some parts of Britain, or we might have actually pollution from smoke from processes taking place within the building. Also, we need ventilation to control internal humidity. If the internal humidity is too high, there's a risk of condensation, especially in the winter months. So we will use ventilation, either natural ventilation or mechanical ventilation, to actually extraction fans, cooker hoods, etc., to remove water vapour where it's been generated. We need to provide air for some combustion processes, and now most gas appliances tend to have a balanced flue, so they actually they bring the air in from outside. But in some instances, and particularly say gas cookers, they will need to have a supply of air for combustion purposes. And during summer, we can open and close the windows to actually during all times of the year really, we can actually sort of open and control the windows to actually sort of regulate the temperature. In the cold we can close the window, or in summer we can open the window to actually sort of control temperature. For part two, we're looking at the main driving factors. Well, the primary one is wind-driven ventilation. And here the speed and the direction of the wind are perhaps the most important factors as the air moves into and out of a building or a dwelling. The secondary factors would be the actual shape and the surrounding sort of environment. And air is going to flow into the building where the wind actually strikes the surface of the building, and then it's going to be sucked out of the building on the leeward side of the building as the air pressures change and pull the air out. Within the urban fabric, you'd expect the wind velocities to be much lower than you would in more rural confines or at the edge of an actual space itself. In terms of sort of strategies, we might actually see cross ventilation where air is pulled in and pulled out of a space, and probably about 5 times the height of the space is about the maximum we can get for double-sided ventilation for effective summer cooling. In terms of single-sided ventilation, that sort of flow distance reduces to about 2.5 times the height of the actual building itself. The second effect, and much more the secondary effect, is thermal effects, and air as it warms expands and becomes less dense, and as it becomes less dense it rises up. If you like, the same principle behind a hot air balloon, where they inject a gas flame into the inside of the balloon, and that heats up the gas and gives it a lift. So what happens is the air will naturally rise vertically upwards, and the amount of ventilation you get depends on the actual temperature difference and the height it actually sort of moves up, gives the actual sort of ventilation of that space. In terms of the actual size of the space, again very much like the single-sided ventilation, about 2.5 times the height of the actual building. But we need to actually make sure that the window can actually be open to its full height, and this is where perhaps windows like sash windows come to the fore.